Here's what happens every time a filtration screen clogs on a conventional extrusion line. Differential pressure across the screen rises until it hits the operator's threshold. The extruder stops. Melt pressure is released. The screen carrier is pulled out, the clogged screen removed, and a clean screen pack installed. The extruder restarts. Then the process needs to restabilize, melt temperature, pressure, and throughput must return to target before the product meets specification again. Total time, 15 to 45 minutes, depending on the screen changer design and the line configuration. During that time, the extruder produces nothing. The downtime cost is the most visible part. On a 400 kg per hour blown film line with a product value of €1.40 per kilogram, a 20-minute stop loses roughly €147 in output. 3 stops per shift, 3 shifts per day, 250 production days, that is over €400,000 per year, from downtime alone on a single line. But downtime is not the only cost. Each restart generates transition material, product made while melt pressure restabilizes after the screen change. On quality-sensitive film grades, this material falls outside specification and is scrapped or downgraded. And during the screen change itself, the melt pressure spike, typically 20 to 40% of operating pressure, propagates through the die and into the product. On film lines, this creates gauge bands. On fiber lines, it breaks filaments. On extrusion coating lines, it causes coating weight variation. The financial impact of these quality effects often exceeds the direct downtime cost. A continuous screen changer eliminates these problems at the source. In a dual-cavity design, one cavity filters the melt while the second is being serviced. The switchover between cavities happens without stopping the extruder. Melt flow is uninterrupted. Melt pressure variation during the cavity switch, within plus or minus 2%. No spike, no drop, no gauge band, no scrap window, no filament break. In a continuous belt design used for high-contamination recycling applications, a moving belt of metal mesh advances fresh filtration area automatically as the loaded section exits. The belt advances when differential pressure reaches the set threshold. The line never stops for the belt advancement. In both cases, the screen management event that previously cost 15 to 45 minutes of production becomes invisible to the process. The OEE impact of switching from manual to continuous screen changing has been documented by AMI Consulting at 5 to 15% on film and fiber lines. On a 500 kg per hour film line, a 7% OEE improvement adds approximately 2,970 kilograms of production per week. That is roughly 150 additional tons per year from the same line with no additional extrusion capacity. Payback periods on lines with screen change frequencies above once per shift are typically 12 to 24 months. After payback, every year of operation recovers the equivalent of the equipment cost continuously. The right screen changer depends on 4 variables: throughput, contamination level, change frequency, and product quality sensitivity. For film, fiber, BOP, extrusion coating, wire and cable, and compounding on clean or low contamination feedstock, a continuous dual cartridge screen changer provides the pressure stability and gel removal capability these applications require. For post-consumer and post-industrial recycling, where contamination levels of 3 to 10% make conventional screen changers impractical, a continuous belt screen changer is the appropriate technology. For lines with very low change frequency and low sensitivity products, pipe, profile, simple compounding on virgin polymer, manual, or hydraulic equipment may be economically sufficient. If you want to calculate the exact downtime cost for your line, throughput, stop frequency, product value, Coffett's free productivity savings calculator gives you the number in under 2 minutes, link in the description. For a complete comparison of all screen changer types, application guides, and technical specifications, see Coffett.com. And if you want to discuss your specific application with our technical team, request a technical alignment through the contact page. Thanks for watching.